This is Pythagoras theorem. Happy resumption to all teachers in Lagos State and students. We are on to our mathematics, SS3. I think the third topic. Mathematics, mathematics. Are you there? Mathematics. So mathematics, SS3. That's the third topic. That is application of solid to trigonometry ratio. Application of solid to trigonometry ratio. Now we have done solid. We have already known how to do rationalization, conjugation, addition, multiplication of solid. Then let's now apply it into trigonometry. And when you talk about trigonometry, we are talking about right angle triangle. Right angle triangle, in which we have our longest side to be hypotenuse. Considering any angle that we are considering here, this is our 90-degree angle at 90 degree. So if we are considering this angle, this will be our opposite, and of course this will be our adjacent. But if we are considering this angle, here will be our opposite, while this place will be our adjacent. So depending on the angle we are considering. Now we want to look at this, applying them, looking at them between angle 0 degree to 360 degree. So it will be, I want to see angle that will fall between this. So let's now look at it. First, in another textbook, they call them special angles. I call them what? Special angles. And these special angles include possibly, majorly we make it angle 30, angle 60, and angle 45. So we have angle 30, angle 60, and angle 45. Let's start from that special angle side. So to get angle 60, this is our right angle triangle that has this place. So okay, before we could get right angle triangle, sorry, let's start with we are going to deal with equilateral triangle. What do I call it? Equilateral triangle. So equilateral triangle is such a triangle where all the sides are equal. All the sides are equal, and likewise all the angles are equal. So if all the sides are equal, all the angles are equal, 60, 60, 60. So it's going to give me 180 sum of angle in a triangle. Then all the sides, we say let them be 2, 2, 2. So from this, we move further to, I want to change this one to right angle triangle, and that is where we bisect it into two equal parts. So this gives me right angle, right? So let me now bring it out. So when I bisect it into two, this side will now be 30 degree, divided into this side will be 30 degrees. So let me take this one out of it. So it's going to give me something like this. Going to give me something like this. So here is 60, and here is what? 30. 30. So we have this side to be 2 according to this place. Now when we divide it into 2, this side will be 1, this side will be 1. So here will be 1. So here will be my x that I'm looking for. So using our name, that is using Pythagoras theorem. Using the rule of Pythagoras rule that said the sum of the sum of the square of two opposite sides is equals to the square of two sides is equals to the square of the hypotenuse. That is, hypotenuse square is equals to opposite square plus adjacent square. So the square of the two sides is equals to the square of the hypotenuse. Now my hypotenuse is 2, so it will be what? 2 square, which is equals to my adjacent. Considering, and if I'm considering this, so my adjacent will be opposite will be this, which is x squared, while my adjacent will be 1 squared. So let's move on. We collect the like terms. Let this one to meet this. So it will be 2 square minus 1 square. 1 square, it will be equals to x square. Therefore, x square is equals to, this one is 2 square minus 1 square. X square now is equals to, this is 4 minus 1. The square of this is 4. So it will now be x squared is equals to 3. Then I'll now say root, take root of both sides. As we know that square is cancelled by square root, while square root is cancelled by square. So I'll take root of x squared, which is equals to the root of this. So this cancel this. And the reason is just this. Whenever they say root x, what it means is x raised to power half. Is this half that make root on this in indices? And don't forget the 2, there is 2 here before, because the thing is x squared. So this 2 just go over 1. This cancel this. That's exactly what it did. There's no any magic there. So this x now is equals to root 3. So therefore, this side is root 3. So with this now, I can look for any of the 3. I can find sine 30. I can look for cos 30. I can look for tan 30. I can equally look for cosec 30. I can look for secant 30, and I can look for cot 30. All this one degree. So as I can look for all this under, I can equally look for their 60 sine 60, cos 60, tan 60, cosec 60, secant 60, and then cot 60. So let's quickly look at them. When I'm not saying sine 60, it means I'm considering this place to be my angle. Then there will be my opposite. And what is sine? Sine is we are following so So sine is opposite over hypotenuse, O over H. So this is my opposite now, facing this 30. Opposite, and this is my hypotenuse. So that one will give me half. And if you look at your calculation, your calculator first will give you 0.5. That's sine 30. Now cos 30. Cos is what? Adjacent. This is my adjacent. As long as this I'm considering this angle, adjacent over hypotenuse. Adjacent over hypotenuse, which is root 3 over 2. Then tan 30. Tan is what? Opposite over adjacent. So that's 1 over root 3. And cosec, as we have known that cosec ordinarily is what? 1 over sine theta. The meaning is 1 over sine 30. That's cosec. Now, sine 1 over sine 30. If we now look at our sine 30, it's just the reciprocal of it. that will give us the cosec of that. So the reciprocal, if we reciprocate this half, it will give us what? 2. It will give us 2. So y secant is 1 over cos theta, which is cos 30. And we just reciprocate cos 30, which will now be 2 over root what? Root 3. And um what do we call it? Cot. Cot is the same thing as 1 over tan 30. 1 over 1 over tan 30. And 1 over tan 30 1 over tan. So 1 over tan 30 is just to reciprocate tan, which of course will be root 3 over 1, which is the same thing as root what? 3. So can we see it clearly? Okay, let's go to sine. Now sine, we are considering 60 now. Sine 60, this will now be my opposite if you are considering this one. Opposite over hypotenuse, that's root 3 over 2. Then cos, my cos is what? Adjacent over hypotenuse. So my cos is always half, which is 0.5. So if you look at sine 30 and cos 60, they always be the same. While sine 60 and cos 30 always be the same. So we have tan 30, tan 60. Tan 60 will now be opposite over adjacent, which is root 3 over 1. Opposite over adjacent. So which is the same thing as what? Root 3. Now when you have cosec 30, just reciprocate sine. So it will be root 3 over 2. Why? Cosec reciprocate this, so that will be 2. Why? Cot reciprocate this, so it will be reciprocate what do we call it? Tan. So it will be 1 over root 3. So that's how to use all this to get when you are asked to use solved form. Now let's quickly move to how do we get 45. 45 is gotten from a square. A square. When we say a square, we use square. And the square is in this form. And of course, you know square with all the dimensions to be equal. All the dimensions are equal. So we say this is 1, 1, 1, 1. Now we now diagonalize it, put it in diagonal. So when you diagonalize it, it will turn to, of course, our right angle triangle. This is 90 degree. This is 90 degree. This is 90. All the angles are equal 90 degree. Now when we diagonalize it, here we turn to 45. It cut it into 2. Here we turn to 45. Or here it remains 90. So let me draw it rightly. So it's going to be in this form. Now it's going to be in this form. So here is 45. This place is also 45. So we have this side, these two sides will be 1, 1. But this diagonal, this is it. We don't know it. So we'll still use using Pythagoras rule. So when we use Pythagoras rule, so it's going to give us the square of hypotenuse, which is this, is equals to the sum of the square of the two other sides. So the square of hypotenuse, this will give me 1, this one will give me 1. So square of this will give me 2. So I take the root of what? Of both sides. Let's take the root of both sides. So this square root of x squared is equals to 2 root. So this cancels this, x is equals to root 2. So therefore, this our hypotenuse is equals to root 2. So this one too, we could use it to get our sine 45, our cos 45, our tan 45, and cosec and tan, cots and the likes. Now sine 45, they are not the same. Anyone you choose there gives you the same. So this is what opposite of hypotenuse, which is what 1 over root 2. Our cos is the what adjacent over hypotenuse, which is also 1 over root 2. Then our tan is what opposite over adjacent, which is 1 over 1, which equals what 1. So let's now solve one or two questions. This type of example under application of such. So we are going to use, when they say insert form, it means you are using your special angle. And mind you, let it ring bell in your head like this. Since you have 30 something, so I know here is 60, I know here is 30, and I know here is 1, and I know here is root 3, and I know so I just put it beside. So let me move on. This will now give me 1 plus cos 30. We know that cos 30 is opposite of hypotenuse, which is 1 over 2. Cos 30, we know that we said cos is what? Adjacent over hypotenuse, which is root 3 over 2. Then we said divided by 1 minus sine 30 is opposite over hypotenuse, which is 1 over 2. So we can continue our solving. Of course, you can do it like this if you like. Depends on how you wish it to be. So I'll solve this one first. And solving this one, I'll have 1 plus root 3 over 2. So I turn this one to fraction over 1. So which will now give me the LCM of this, of course, will be 2. 1 into, that's 2. 2 times it, that's 2 plus 1 in 1, 2 into 1, 1 times root 3. I have this root 3. We are going to have this as the answer of this. Now let me now solve this. This one will give me 1 minus 1 over 2. This one will now be 1 over 1. The LCM will be 2. So I have 1 in 1, 2, 2 times this. So 2 minus 2 into 1, 1 times 1, 1. So of course this one will give me 1 over 2, the total of this one. So I'll now divide, since this one will come and stand in place of this, which will give me 2 plus root 3 over 2 divided by 1 over 2. So this one will forward give me 2 plus root 3 over 2 times this one reciprocates 2 over 1. So this can cancel this. And this will now be 2 plus root 3 as my answer. Question. So we have to evaluate without using table. Without using table, we put it in sort form. So since I have seen 45 there, I'll quickly draw that of 45, which shows me that this place is 45. Here is also 45. 1, 1, root 2. And I've seen 30 there. Let me draw that of 30, which is 60. This one is 60. 30. I have 1. I have 2. I have root 3. So I'm putting it beside so that it will guide me. So let's move on. We have 1 minus sine 45. Sine 45 is opposite over hypotenuse, which is what? 1 over root 2. 1 over root 2. Okay? Divided by 1 plus cos 30. Now, cos 30, this cos 30, and that is adjacent over hypotenuse, which is what? Root 3 over 2. So we can continue by saying 1 minus 1 over root 2. That is, I want to deal with this numerator first. So this one will be over 1, and that will give me my LCM will give me root 2. 1 in root 2, of course, it will give me root 2. So root 2 times 1, it will give me root 2. Root 2 and root 2, 1. 1 times 1, 1. So this is the answer is the first one will give me. So that is from the numerator. So I come to this denominator, 1 plus root 2, root 3 over 2. This one over 1. My LCM, of course, will be 2. 2 in 1 in 2, that's 2. 2 times 1, 2. 2 into 1. 1 times root 3, it remains root 3. So I've gotten this is my numerator and this is my denominator. Let me now combine them. I have root 2 minus 1 all over root 2 divided by 2 plus root 3 all over 2. So now what do? I change this my multiplication. So it will now be root 2 minus 1 all over root 2 times, this one will now reciprocate. So it will be 2 over 2 plus what? Root 3. Now if you look at it now, I can multiply it out. And multiply it what? Out. So it's going to give me root 2 minus 1 all multiplied by 2 divided by this one multiplied by this multiplied by this. Root 2 multiplied by 2 plus root 3. So let me now multiply it out. 2, I will expand this bracket. 2 times root 2, of course, that will give me root 4 minus 2. Sorry, I said this 2 times this, sorry, to give me 2 root 2. Because this doesn't have roots, so I will not say root 4, of course, minus 1 all over, sorry. So this multiplied by this is give me 2 root 2 plus, and this one will give me root 6. Since they are roots, I can multiply inside. But when it does single without root, it will be outside. So let's move on. Now, if you look at this, you will see that I can't leave my answer in this form. Since a sword has to be rationalized in order to be in perfect way. So I will now do what? Rationalization. I do rationalization. So that will give me 2 root 2 minus 1 all over 2 root 2 plus root 6. So when I want to rationalize, I deal with this denominator. Of course, it will be in a conjugate form because you look at conjugate. So when it is positive, it changes to what? Negative in the same proportion. So 2 root 2 minus root 6. 2 root 2 minus root 6. So you see that this one is just 1. It's the same thing. Now I continue expansion. Let me continue from here. It will now be 2 root 2 minus 1 multiplied by 2 root 2 minus root 6 all over. And I join the one and down 2 root 2 plus 6. So if you look at this very well, the denominator, it was difference of 2 square. Difference of 2 square. So of course, it makes my work much easier. Now, the one on top, I can expand by multiplying this and this and this, so that I can move on. So don't try to cut, no. So if I multiply this, it will give me 4 root 4. This and this. 2 times 2, this times this. So when I multiply this and this, it will give me minus 2 root 12. Minus 2, this time this is what? Root 12, because they are roots. Now I'm done with this, I come to this. Minus, if we want to multiply this, it will remain the same. Are we? So this times this, it will be plus. So 1 times that, of course, it will give me root 6 divided by. So let me do the same thing. This multiplied by this first. So that will give me 4 root 4. So the same this one multiplied by this. That give me minus what? 2 root 12. And I'm done with that. Then I come and use this again to make my expansion. This multiplied by this plus what? Plus 2 root 12. Plus 2 root 12. This multiplied by this minus root 36. So I can move on by having this. So root 4 is 2. 2 times 4, 8. Are we there? So minus, and this is root 12. Of course, this root 12, I can turn it to 2. 12 can be 4 times 3. So that I can have one, I can still reduce it. 12 times 3. So this one on top is now 2 root what? 2 plus this one is root 6 all over. This, of course, will give me the same 8. And this, if you look at it, their sword is the same thing. Therefore, I can do what? I can manipulate them. So this one is minus 2. This is plus 2. They will cancel themselves. So, and this one is like root. That's 6. So, because square root of 36. So, this one, I can still move on. 8 minus. So, this one will now give me 2. 2 times 2. 4 root 3. It's only 3 that will be carrying root now. So if you have not gotten this sort very well, go to the second video where we did sort for SS3. So this one now be minus 2 root 2 plus root 6 all over. If I subtract this one, is going to give me 2. It's going to give me 2. So if you look at this very well, I can continue. So I detected there is a particular mistake here in this expansion. In this expansion, 2 times this one is going to give me 2, of course. So it's affecting my procedure. Now here is going to be 2. Of course, if we now move up here will be 2. So this 2 now, if we multiply it by this, is giving me 2 times this. When we are expanding here, of course, it's giving me 4, right? So 2 times this is going to be on this 4. So the 2 times this is going to be 2 root 6. 2 root 6. So this one also will give me 2. Don't mind me, that's how mathematics are sometimes. When you get to a stage, you will be looking at the 40. So this one is also root 4. So if we get to this place, we still have what? Root 6. And here will give me 4, of course. So with this, why I look at it that way is that I'm looking at it, can we factorize? We factorize. So when we factorize the numerator, you see that 2, we can see 2 here, 2 here, 2 here, 2 here. So we bring the 2 out, open a bracket. This one will remain, if you divide it by it, 4. This one will remain 2 root 3. And this one will remain 2 root 2. And this one will remain root 6. All over 2. So these 2 will cancel. So our final answer will now be 4 minus 2 root 3 minus 2 root 2 plus root 6. So that is it. So it's just the mistake of expansion here. So 2 times this, it will give us 2. So it affects it. So I thought as much that when we get there, the thing's supposed to give us something like that will be factorizing most of the question. So we are going to end the class here, and this is how to deal with it one after the other so that we can at least achieve one. Have a nice time and have a nice weekend.